Okay? We have 20 meters per second, and then our final velocity will be 0 because the car can only travel for 8 seconds. Okay, 8 seconds. So, or we can say, we can also use this to be our final velocity, but since we are considering where the car will stop, okay, the car has only 8 seconds to move, and that 8 seconds it has to move, it can apply, the driver can apply 2,000 Newton brakes to it. So that is the time the car can move, 8 seconds. And when it moves that 8 seconds, 2,000 Newton of force is applied to the brakes for the car to stop. Okay, now, we have the first, from equation of motion, we have the equation, which is S to be average velocity multiplied by time. This is one of the equations of motion, but most often than not, we don't use it. Okay, because most equations given to us will either say acceleration there or time. But in this case, we need it because it contains these 4 parameters. In the previous videos I did, I've taught us how to use the equations of motion. Any equation that has the parameters, 3 parameters are there that you're going to be given, and the one you are looking for. All right, now follow me. So S will be V, the final velocity 0, plus U, initial velocity 20 over 2, and our time is what? 8. So what do we have? S is 20 times 8 over 2. 2 here, 1, 2 in 8, 4. So our S is what? 80 meters. Now, what does this imply? It implies that the car can only travel, in this context, can only travel for 80 meters for the brakes to be applied. And also, when the brakes are applied, when a force is applied to stop the car by applying the brakes, it means that the car would have moved for only 8 seconds. Only 8 seconds. Now, the total distance the car can travel when the brakes are applied is 80 meters. And we are told that a dog is 50 meters away from the car. What does that tell you? It means that the car will go, follow me, it will move past these 50 meters. The car can cover how many meters at this point? Is where the car will stop. Car, stop. Let's say car moving, okay? So, the car will stop at this point, and at this point it would have covered what? 80 meters. What does that tell you? Looking at option A, the car will be able to stop immediately the driver notices the dog. It's a lie. Because from what you have saw, from this equation, from what you have saw here, it shows that the car will pass the dog. Okay, because the dog is at a distance of 50 meters from the car, so the car will pass the dog. That's one. So option A is wrong because the car will not stop immediately the driver notices the dog. It will keep on moving. Okay, because the distance it can cover is what? 80 meters. Don't forget. Option B, the car will stop 30 meters after hitting the car. That seems correct. But let's check other options. We'll come back to that. Option C, the car will stop 20 meters in front of the dog. Wrong. This is where the car is. So our answer, the result we'll get will tell us where the car will stop and the distance it will stop. So option C is wrong because the car will move past the dog. Option D, the driver will quickly reverse the car. That's wrong because they're driven past the dog. Option E, the car will stop 5 meters beyond the dog. Now, beyond the dog after hitting the dog. So we're looking at option B and option E. What does this tell us? If the car stopped here at 80 meters, what's the distance now between the car and the dog? That will be 80 minus 50. And that will give us what? 30 meters. From our calculation, we can conclusively say that the car will only stop. This is where the car will stop. It will only stop 30 meters after hitting the dog. Meaning the car will hit the dog. And when it does that, it will stop. Don't forget, at this point, that's when the car will stop. And it will stop after hitting the dog. So the answer is option B. Now, you see how we use physics to solve real life problems. That is the beauty of mechanics. Please like share, and follow me for more practical illustrations on mechanism. Thank you.